Hi all, I'm T. Shaktishri, Assistant Professor of Department of Information Technology, Hindustan College of Engineering and Technology. Welcome you all for a video lecture on stack. In this lecture, we are going to learn what a stack data structure is, what are the basic operations that can be performed in a stack, and what are the various types of implementation that are available for the stack. Stack. Stack is one of the most important and popular linear data structure which is widely used in the field of computer science. It follows the principle of last in, first out. The element which is inserted at the last is the one which will be removed first. A stack can be called as an ordered collection of items in which insertion and deletion can occur at only one end called top of the stack. Example of stack can be a stack of coins arranged one above the other, stack of plates, the tennis balls arranged inside a can one above the other, or the books arranged one above the other. Let's see the basic operations that can be performed on a stack. The operations that can be performed on a stack are push, pop, peek is empty and is full. Push is inserting an element into the stack, pop is removing or deleting an element from the stack, and peek refers to displaying the topmost element of your stack. Is empty is used to check whether the stack is empty or not, and is full is used to check whether the stack is full or not. Now let us see the basic operations with the help of the diagrammatic representation. Let us assume that our stack is initially empty. If we push an element 1 into the stack, it will be placed in the first position, that is at the topmost element, as the stack is empty. The next is we are trying to push an element 2. So now after 1, the current element 2 will be pushed. Again we are trying to insert an element 3 which will be placed above 2. And in the next operation we are trying to do a pop operation, which is removing or deleting an element from the stack. As you know, in stack it follows a last in first out principle. So the element which is inserted at the last will be deleted first. So the element 3 will be deleted. So whenever we do insertion and deletion operation, two exception condition has to be checked over here. One is overflow and second thing is underflow condition. An overflow is an attempt to insert an element when the stack is full, and underflow is an attempt to delete an element when the stack is empty. So whenever we do an insertion operation, overflow condition has to be checked, and whenever we do a deletion operation or the pop operation, underflow condition has to be checked for the smooth running of the insertion and deletion operations. Getting into the implementation of stack. Generally, whatever the data structure it might be, there are two ways of implementing the data structure. One is array-based implementation and second is linked-based implementation. Array-based implementation is static and linked implementation is dynamic. So let us learn how array-based implementation and linked implementation is being done in stack. Now let us see the array implementation of stack. For the array implementation of stack, it uses arrays to create a stack and then a variable called top, which is being initialized with the value of -1. Getting into the first basic operation, push operation. Push operation is termed as adding an element onto the top of the stack. Push operation can be performed in two steps. First step is incrementing the top variable by 1 and then adding the element to the current position. Whenever we do an insert operation, an overflow condition has to be checked to check whether we have enough space for inserting the new element. Now let us see the example of insertion operation. Initially our stack is empty and the value of top variable is -1. If we want to push an element, let us take for example if we want to push 12. First operation which has to be done is top value has to be incremented by 1. The top value refers to the index position of an array. So now it points to the value of 0. So at that current position, the new value 12 will be inserted. Next, let us try to push another element called 20. On doing this, first top value has to be incremented by 1, which will point to the location 1, that is the index position 1, and in that current position, the element 20 will be inserted. Let us try with another push operation of 45. Now already the top value is at 1 as it has been incremented, it goes to the position 2, and in this current position, the new element 45 will be inserted. So the elements are inserted in the order 12, 20 and then 45. Getting into the implementation detail of the push. So whenever we do a push operation, the first and foremost thing which has to be checked is that whether a stack is overflowing or not. Because as in array, we'll be having only a static implementation. So we have to check whether we have an enough space for inserting an element. If we have an enough space, then we can increment the value of top by 1 and then put the new element into that top position. If not, we have to display a message like stack overflow. Pop operation. Removing or deleting an element from the stack is called as a pop operation, and this also involves two main steps. First thing is that the topmost element of the stack has to be placed in another variable, and then the top variable has to be decremented by 1. After that, the pop operation has to return the deleted element. So as like insertion operation or push operation, here too during the pop operation we have to check for the underflow condition, because we will not be able to do it pop operation in an empty stack. So we have to check for an underflow condition whenever a pop operation is being done. Let's see the example of a pop operation. Let us assume that a stack contains the items 12 and 20. So the top pointer will be pointing to 20. So if a pop operation is being done, the topmost element will be deleted. The deleted in the sense the value 20 will be placed in some temporary variable, and then the top value has to be decremented by 1 so that it will make it to point to the next element. Getting into the implementation detail, as already mentioned, we will not be able to perform a pop operation in an empty stack. Only if we have some elements, we will be able to do a pop operation. So we have to check a condition like whether a top is equal to -1. If it is not equal, then it means that the stack contains some elements, and we will be able to do the pop operation by displaying the element or retrieving the element and then decrementing the top pointer by -1. Next we are going to see about peak operation. Peak operation refers to returning the topmost element from the stack. Here in peak operation, we are not going to remove the element from the stack. We are just going to display the topmost element. So here too we have to look for a condition like whether the stack is underflowing or not, because we will not be able to show any elements in an empty stack. So in the diagram we have a data content like that is stack content like 12 followed by 20. So if a peak operation is being performed over here, the element 20 will be displayed. Advantages of stack. It requires no extra memory. Here we are just going to store the content. Unlike linked implementation, we won't be storing any pointer over here. Next advantage is it is more efficient in terms of time when compared with the linked implementation of stack. Getting into the disadvantage of array implementation of stack, the size of the stack is fixed. So we will not be able to increase or decrease the content of the stack. And another thing is that insertion and deletion in an array are quite difficult, because we will not be able to insert an element in between the stack. If we want to do the insertion, few arrangements has to be done so that the insertion and deletion can be done successfully. For that, it takes more amount of time. Now, let us see the linked implementation of stack. For the linked implementation, each and every data will be represented in terms of a node. A node here is a self-referential structure. A structure which refers to itself is called as a self-referential structure. In this particular structure, we have two parts. One is data and second is a pointer pointing to the next element. The above is the diagrammatical representation of a linked implementation of stack, where we have the elements 12, 35, 10, 45 arranged in a sequential manner. The first element that is inserted here is 12 followed by 35 and then 10 followed by 45. Here the top refers to the element which is being inserted at the last. Whenever we do insertion operation, that is push operation, the top will be made to do some alterations such that the top pointer will point to the current new element. So let us see how the push operation being done over here. So in the given example, the current content of the stack is 12, 35, 10 and 45. So 45 is the topmost element which is being pointed by a pointer called top. So let us assume that we want to insert an element 50 into the linked implementation of a stack. So what will happen is that a new node has to be created with the element 50. And after that we have to make two new changes. One is we have to make the new node pointer, that is new node of next, to point to the top, and then make the top pointer to point to the new element, that is a new link will be created. If we do this change, automatically 50 will become the topmost element of the stack, followed by the old elements, which is 45, 10, 35 and then 12. Pop operation in linked implementation of stack. Pop operation is very simple here. The first thing what we can check is that we have to check whether we have any elements to delete. So check whether if top is equal to null. If the top is null, which means that the stack is empty. So if the top is not null, we can make the pointer pointed, or the element which is being pointed by the top, to point by another element called temporary. And then make the top to point to the temp of next and delete the temporary element. So in this example, temp will point to 50 and now top will point to 45. So the element 50 will be deleted so that the current content of the stack will be 45, 10, 35 and then 12. Peak operation in linked implementation of stack. As we know, peak operation is just displaying the topmost element of the stack. So it is enough if we just display the element which is being, or the data which is being pointed by the top pointer over here. So before doing peak operation, we have to check whether the stack is empty or not. So for checking the stack emptiness, check whether the top is equal to null. If the top is equal to null, then it means that our stack is empty and we don't have any content to display. If not, we can just display the top element of the stack by making use of top of data. Now let us see the pros and cons of linked implementation of stack. First and foremost advantage of linked implementation is that it is dynamic in nature. We can grow as well as shrink our data structure whenever there is a need, which is not possible when we make use of the array implementation. And here we don't have any wastage of memory, unlike array where we will be having a fixed memory size. For example, if we have an array size of 100 and we are just making use of 10 memory spaces, the remaining 90 will be wasted. But that is not the case when we go for the linked implementation of any kind of data structure. And insertion and deletion in linked implementation of stack is more easier when compared to the array implementation of stack. Getting into the disadvantage of making use of linked implementation of stack is that for storing a single element, we are in need of a pointer to. For example, if you are in need to store an integer, usually an integer occupies 2 bytes. So for array implementation, only 2 bytes is enough. But when we get into the linked implementation, for the data 2 bytes and additionally 2 more bytes has to be allocated to the pointer pointing to the next field. So for a single data or for a single integer, we are in need of 4 bytes. So this is the main disadvantage of making use of a linked implementation of stack. I hope this lecture makes you to understand what a stack data structure is, what is the principle that is being followed over there, and what are the basic operations and how those operations are being done in array implementation of stack as well as linked implementation of stack. Thank you.